Hello, Chem 110. This video is the introduction to stoichiometry. And stoichiometry is simply how much product can I make, or how much reactant will I use for a specific chemical reaction. And so I'm going to take you through a few different types of stoichiometry problems today, but they all start with a chemical equation. And so I've written one here. This is the reaction of phosphine, pH3, with oxygen, O2, to form P2O5 and something you might recognize, H2O, or water. So I just want to look at this equation, first of all, and say the things on the left are what we call the reactants, and the things on the right are the products. The little subscripts here, like this, the L means liquid, the S here means solid, and the G means gas. And, it takes some getting used to know the form of different compounds. And sometimes, water, for instance, sometimes is in reactions as a liquid, sometimes it's as a gas or steam. So, you aren't at this point expected to know these things, but when you do know them, it's good to write them. So the first thing we have to do is balance the chemical equation. We have to have the same number of atoms in the reactants as we have in the products. We're not allowed to create matter in a reaction, we just rearrange the matter. So to do this, the best way to approach balancing is to find something in your equation, you don't always have this, but often you do, that is by itself just one element. If you have that, it's really helpful. And here we do, because oxygen here is by itself. And so the trick is, let's balance this one last, because if we change how much oxygen we have, it won't mess up anything else. All right, so we balance an equation with coefficients. So for instance, if I start with phosphorus, I see I have whoops, that wasn't what I meant to do. I have one phosphorus here on this side, and I have two here. I can't create phosphorus, so I'm going to go ahead and put a 2 here in front of my pH3. Now I have two phosphoruses, phosphori, I don't know, and so that's good. If we look at the hydrogens, we see now that I've balanced the phosphine here with the 2, I have 6 hydrogens here because I have 3 as a subscript times this coefficient, right? So I have 6 total hydrogens. Right now, on this side of the equation, hydrogen only appears in H2O, and I have 2 of them. So to balance that, I'm going to multiply my H2O times 3, and now I have 6 hydrogens. Okay, so my phosphorus, my hydrogen are balanced, and the last thing I'll do is oxygen. So this one's a little trickier. Right now, oxygen on the left side, the reactants, I have 2. And over here, I have 5 in this compound, plus I have 3 because I have 3 waters. 3 times 1 gives me 3. So a total oxygen here of 8. So I need 8 on the left, so I'm just going to go ahead and multiply my O2 by 4, and that makes 8 oxygens. And it didn't, as I said, it didn't do anything to the phosphorus and the hydrogen because I saved the oxygen for last. So that's what we call balancing by inspection, and that's all you'll be expected to do in this class. We're not going to try to trick you with super tricky balancing equations. All right, so the first step in stoichiometry is to balance the equation. Once you have a balanced equation, you can use that to look at ratios between things. So for instance, the first question here is, how many moles of P2O5 do you make by burning 3 moles of phosphine? So I want to emphasize that this is all stoichiometry problems are dimensional analysis problems. So you've been practicing that a lot. You start with a starting point. And so your starting point here is 3.0 moles of phosphine. And the end point, so this is the starting point, and the end point you want to get to is moles, P for endpoint, of P2O5. So here I want to end up with mole of P2O5. So to do that, I need a ratio between mole of pH3 and mole of P2O5. And that ratio comes from the balanced equation. So you go up and look at the coefficients, and I can see P2O5, okay, there's actually no coefficient here because it's a 1. The 1 is sort of implicit there. So for every 1 mole of P2O5, I have 2 moles of pH3. So now this is a dimensional analysis problem, right? My moles of pH3 cancel, and I just divide the numbers, and my answer is 1.5 mole of P2O5. Okay. So similarly, so that was a question where I asked something about how much product I can make. You can ask a question that about any ratio within this equation. This particular reaction has 2 reactants and 2 products, and the coefficients there tell us the ratio between all of them. So in this problem, the question is how many moles O2 do you need to react with 5 moles of phosphine? So again, our starting point is the 5.0 moles phosphine, and we want to end up with moles of O2. So we look at our coefficients and we see we have 4 moles of O2 because of the 4 here for every 2 moles of phosphine. And you'll notice I talked about this when we did compounds and atoms, that when you're changing substances, you really need to write the substance, right? There are moles all over the place here, but it's very important which ones are moles of phosphine and which ones are moles of O2. So in this case, we end up with 10 moles of O2. Okay, so the last problem I have here is a little more complicated because it doesn't ask me about moles, it asks me about grams, right? So my starting point is 1.25 grams of phosphine. My end point is grams of H2O. The equation up here gives me a mole ratio. So I need to get to moles to convert from pH3 to H2O. So I'm going to need some molar masses. So I'm going to need molar mass of water, which is 2 times the molar mass of hydrogen plus the molar mass of O. So this is the molar mass of water. And I'll need the molar mass of phosphine, pH3. So the molar mass of phosphorus plus 3 times the molar mass of hydrogen equals, so phosphorus is 30.97. So the molar mass of phosphine is 34.00 grams per mole. So I start with my starting point, 1.25 grams of phosphine. To convert it to H2O, I have to get to moles. So I'm going to put 1 mole of phosphine on the top, so the grams of phosphine cancel. And again, I think it's really helpful to take the time to write the substance. So now my grams of phosphine will have canceled. And now I can go ahead and get rid of moles of phosphine by changing it to moles of water, which is what I'm after. And so I'll scroll up to remind myself what the mole ratio is. I have 2 moles of phosphine for every 3 moles of water. 3, 2. So my moles of phosphine have now canceled. I'm at moles of water, and the question asked me to answer it in grams. So I will say 18.02 grams of water per mole of water. Now my moles of water have canceled out. Whoops. And I have grams. And I believe if you multiply all those numbers together, you should have 3 sig figs in this problem, and it's 0.994 grams of water. All right, so there's an example problem here I'm going to ask you to do, but I just want to give you the general process for a stoichiometry problem. So I like to think of this as a mole box. Here's my mole box. Inside my mole box, I go from moles of A to moles of B. And the ratio here is from the balanced chemical equation. Moles of A to moles of B. And so coming into here, I have moles of A. Coming out, I have moles of B. And I can do all kinds of other stuff on the left and the right. So I might have grams of A coming here. I might want to go to grams of B. But this ratio in the middle, and actually the way I wrote it is sort of silly because I kind of wrote it upside down. Actually, I'm going to go ahead and, whoops, erased my mole box and go ahead and make it the way you'd have it. If you were actually going from moles of A to moles B, you'd have mole of A on the bottom, right? And mole of B, and you'd have some ratio, right? It would be like X moles of A, Y moles of B, and that's from your balanced equation. Every stoichiometry problem has a mole box in the middle. How you get into there, so we did a problem with molar mass. We could use density, we could use concentration, we could use all kinds of things. All right, so now I'm going to show you this example problem. Ammonium sulfate, the formula there is prepared by reacting ammonia with sulfuric acid. So the first step I ask you to do is what you have to do, even if I don't ask you to do for any stoichiometry problem, write a balanced chemical equation. And then I have a question involving moles, and then a question involving grams. So you can go ahead now and stop the video and try this problem, and then come back whenever you'd like to see the answer. Okay, so my answer is, so we're reacting ammonia, which I happen to know is a gas, you might not know that, plus sulfuric acid. Generally, this is actually a new physical state. It's usually aqueous. It's fine if you didn't write physical states here. I wouldn't expect you to know that. And we're going to make NH42SO4, which is a solid. So to balance that equation, there's nothing alone here, so but I've given you one that isn't very hard. So I'm going to start with my nitrogens. There's a 2 outside this parentheses, so I have 2 nitrogens here and 1 on this side. So I'm going to multiply this times 2, and now I have 2 nitrogens. My sulfur and oxygen are all fine right now, 1 to 1. So let's look at our hydrogens. I have here 8 hydrogens, 2 outside the parentheses times the 4 inside. Here I have 2 hydrogens in this compound, and I have 2 times 3 is 6. So 6 plus 2 equals 8. So we're all balanced. We just needed that 1, 2. So our sulfurs are balanced because sulfur shows up as in SO4 on both sides. Okay, so that's A, done. All right, B. if you made 0.16 mole ammonium sulfate, how many moles of ammonia did you react? So my starting point is, it's not the starting point of the reaction, but it's the starting point of this problem. I have 0.16 moles ammonium sulfate, and I would like to convert it to moles of NH3. Well, I just balanced this and saw that I have 2 moles of NH3 for every 1 mole of ammonium sulfate. So I used 0.32 moles of ammonia. And then the last one uses grams. How many grams of ammonium sulfate can you make by complete reaction of 15 grams of ammonia? So I'm going to need 2 molar masses here. I can see I'm going to need the molar mass of ammonia, which is the molar mass of nitrogen, plus 3 times the molar mass of hydrogen. So nitrogen is 14.01. So the molar mass of ammonia is 17.04 grams per mole. The molar mass of ammonium sulfate, you have to remember that 2 outside the parentheses, so it's 2 times the molar mass of nitrogen plus 8 times the molar mass of hydrogen plus the molar mass of sulfur plus 4 times the molar mass of oxygen. So 14.01 for the nitrogen, 1.01 for the hydrogen, 32.06 for sulfur, 16.00 for oxygen, so 132.16 grams per mole. Okay, so our starting point is 15 grams of ammonia. So 15 grams of ammonia. I need to change it to ammonium sulfate, so first I need to change it to moles of ammonia using the molar mass. So that will get us to moles of ammonia. And then our ratio from the balanced equation is that I have 2 moles of ammonia for every 1 mole of ammonium sulfate. So just to make sure we're keeping up with the units, we got rid of grams of ammonia. Now we got rid of moles of ammonia. We're now at moles of ammonium sulfate. And so the last thing we want to do is turn it back to grams because the problem asked us to do that. So 1 mole, oops, sorry, I just messed that up. 1 mole of NH4 2 SO4, we decided is 132.16 grams. So now we've gotten rid of moles of ammonium sulfate. And I believe if you multiply that through, you get 58.17 grams of ammonium sulfate.